So, hello, good evening. Welcome to the 12th problem solving session for the. Just give me a minute. So, good evening and welcome to the 12th problem solving session for the course Municipal Solid Waste Management. So, the course instructor is Professor Ajay from Department of Civil Engineering, IIT Guwahati, and I am one of the TA for this course. My name is Asma Parveen, and I am a PhD scholar from IIT Kanpur. So this is the technically the last problem solving sessions based on the 12-week content of the this course, that is Municipal Solid Waste Management. So there will be one more problem solving session that will be on next Saturday for 2 hours. So basically, in this for the previous 11 problem solving sessions, so in this problem solving session, we will be discussing about basically, I will give a brief recap of what was taught, what was there in the lecture slides, and then we will try to solve few sorry, not numericals, a few multiple type questions, and then that will be all for today's session. So, we have started this course from basic definition of what is municipal solid waste, what is basically solid waste, what are the various classifications of the solid waste, what is municipal solid waste, what are its classification, and what are its composition, and what are the parameters or properties, like what are physical, chemical, and biological properties of municipal solid waste. Then we have discussed about collection system for the municipal solid waste. We have discussed about door-to-door collection, which is called as collection services. Then we have gone to the overall collection from the bins to the transfer station or to the processing or disposal side, that is known as collection system. Then we have discussed about two types of collection system, the hall container system and the stationary container system. And then we have moved to transfer stations, and transfer stations are the small are the stations where the waste from the entire city or from a part of the city is taken, and from transfer stations it is further sent for processing or disposal. And then we have discussed about what are the various methods for processing of the waste. Like we have discussed about what are the various physical methods, like sorting, first of all collection, and then sorting of the waste on the base of its particle size, then screening, and so on. And then we have discussed about what are the various methods for chemical transformation. Like we have discussed what is incineration, gasification, and pyrolysis. So incineration is combustion of something into presence of excess air. So there is more oxygen than required. That there is more oxygen than the stoichiometric requirement for any compound or substance to burn. And then we have discussed about gasification. So gasification is a combustion in lesser amount of oxygen or air than the stoichiometric requirement. And pyrolysis is something which is done in absence of air. So incineration. So incineration is an exothermic process, whereas pyrolysis is an endothermic process because we need some initial amount of heat or energy to heat the reactors, and then pyrolysis takes place. But the end product, since there is difference in the amount of air, oxygen or air is supplied, so the end products will depend upon that. So in incineration, there is complete combustion. So we get CO2, that is carbon dioxide with water, and there are various other gaseous pollutants in the final the gas which is produced. But in gasification and pyrolysis, we get syngas or synthetic gas in which there is methane present. So methane, CO2, water, and other trace amount of compounds are there in the gas. So since we are getting methane, so this can be used for further purposes. Like this methane can be used to produce electricity, or it can be sent to various industries which require energy. So now also from gasification and pyrolysis, we get other than the gaseous product, we get bio oil. So with condensation of the particles into the gaseous phase, we will get a liquid product, which is the bio oil, and the solid product which is left is known as char. And from combustion, we get ash because everything has been burned. So the final solid product will be ash, and the gaseous product we get is mainly carbon dioxide and water. So after the thermal processing, this is basically a combination of thermal and chemical conversion. So after that, we have moved to the biological processing. So in biological processing, we have discussed about composting, and then we have discussed about vermicomposting. So in composting and vermicompost, so in basically in composting, there is a degradation of the waste, or a conversion of the waste into organic matter or into lesser complex organic matter by microorganisms. So these microorganisms or microbes feed on the organic waste. Basically, they are the aerobic microorganisms. So they feed on the organic waste, and they convert the organic waste into um, lesser complex form and more valuable in terms of application in the soil. So during composting, there is a large amount of nutrients, like there is nitrogen present into the compost, which can be supplied to in the agriculture fields, and that can enhance the growth of the plants and others. But since we are converting something by microbes, and we are since we are processing some waste, so first thing we have to see that this waste does not have very high amount of contaminants. If there is a very having very high amount of heavy metals, like if there is very high amount of cadmium, lead, or zinc, especially cadmium, lead, chromium, arsenic, so if these are very high, so we have to then, so we basically do TCLP test, that is the toxicity characteristic leaching procedure test. So in this test, for what we do, we take some amount of solid waste and then we extract this into some extractant. So, and in that extractant, after around 16 to 20 hours after mixing or shaking the sample, we take filter that extractant and measure the heavy metals in that. So if in that extractant the heavy metal concentration is more than the permissible limit or more than the TCLP limit, then it means that we regard that waste as hazardous and we do not process that waste. Rather, that waste is processed and disposed by following the hazardous waste management rules. So, if the municipal solid waste heavy metal concentration is lower than the TCLP limit, then we can safely apply that into the fields. Otherwise, we cannot use that in the fields. So, since also heavy metal is something which gets accumulated in the soil, and if it is in bioavailable form, so it will be taken by the plants, and it can go into the various parts like leaves or fruits and others, and it can be consumed by humans and other animals. And slowly in human body also there is accumulation of the heavy metal with time. So with longer consumption of these fruits and other vegetative plants, so this can cause various diseases in humans and animals. So this is very important to first check the concentration of heavy metals before applying to the field. So next we have discussed about vermicomposting. So vermicomposting is done by using some earth forms. So earthworms eat the organic matter and their excreta is the compost which can be applied into the agriculture field. So the basic difference between composting and vermicomposting is that in vermicomposting we are using earthworms to convert the waste into the compost. There are various types of earthworm which are used for this process, and then we have discussed about anaerobic digestion. So anaerobic digestion is or degradation of the organic matter by microbes in absence of oxygen. So basically these microbes are the anaerobic microorganisms which feed on the waste and they convert this organic matter into methane. So here methane is the uh, product which we get in aerobic decomposition or in other aerobic decomposition. In fact, in composting, there is aerobic decomposition, so the end product will be CO2. But in anaerobic decomposition or digestion, we are getting methane as the end product. So methane is a greenhouse gas, we know that, but it is has very high calorific value and it can be used to produce energy, or it can also be burned to do various things, like it can be used in cooking as well. So this is the advantage of anaerobic digestion. We are getting methane, which can be used for various purposes. So, but oxygen is one barrier for anaerobic digestion. If there will be oxygen in the reactor, so this will not proceed. So, also for like anaerobic digestion, as compared to the aerobic microbes, their growth hill or their uh, the time in which they increase their masses is very slow. So this process takes time as compared to the aerobic degradation. So after that, we have discussed about I think recycling was before this only, that we have discussed about how to do the metal recycling and how to do the plastic recycling and so on. So and then So after all these processing methods for the waste, we have moved to disposal, final disposal, that is in the landfills. So earlier in our country, there were still now also there is open dumping of waste rather than engineered way of putting the waste into the landfills. So in landfills, waste is put on the landfill every day, and after proper compacting and sealing of the waste by using some material like soil or compost, this is totally, the waste is totally covered, and since it is covered, it will not be available for rodents and rat pickers, and it cannot be blown away by air. So landfilling is bad. So we have discussed about what are the types of landfills, what are the various equipments and instruments that is required. Like we have discussed, there is the production of leachate. So leachate is something which, when there is rain and also during it, since there will be some fraction of biodegradable organic matter in the waste that will get degraded with time. And since in degradation, we know that water is the end product which is produced along with CO2. So water will be produced, and if there is rain, then that water and CO2 along with the other pollutants that will be produced, that mixes with water, and they comes out of the landfill, and they can go and pollute the groundwater, or they can go and pollute to the surface water. So this is leached. Also, there can be cases where the groundwater increases and the groundwater goes into the landfill, and there is production of lot of leachate. So there should be proper leachate management and collection and treatment either at the site or taken to the some treatment wastewater treatment facilities where their leachate is treated. So this leachate will also have nutrients, because any organic matter have oxygen, nitrogen, sorry, CHNS, that is carbon, hydrogen, nitrogen, sulfur. These are the main compounds. So through degradation of the organic matter, so nitrogen will be there. So ammonia will be there. Will be a lot of ammonia and nitrate into the leachate. So there should be proper technology to cover this nutrients and recover this nutrients and then reuse it. So also during biological degradation, various microbes converts the product into there will be a solid product, there will be liquid product which goes to the uh, which is called as leachate, and there will be a gaseous product which is known as landfill gas. So this gas, if there will be if the landfill is covered, and also if the landfill is not totally covered, so top layer have some oxygen, and in fact during filling and compacting there is some oxygen particles that remains in the waste. So initially there will be aerobic degradation, and after some time this oxygen will be consumed, and this process will convert into anaerobic, and during anaerobic degradation we know that methane is produced, and so this methane, there should be proper management of this methane, because since it is a very this has a very high potential for global warming, so much more than the carbon dioxide. So this should be properly trapped, and since it has very high calorific value, so it can be used to produce energy and electricity. So after landfill, so there was 2 week lectures on landfill. So after landfill, we have discussed about some special type of waste in the last week module, that was in week 11. So there was a discussion about construction and demolition waste. So these are produced from, as its name is, construction and demolition from construction activities. So there is these waste should be managed as per the rules. So there should be proper recycling of the materials from this construction and demolition waste, and that should be reused either at the site or at some nearby places, because these waste are very bulky. It has totally inert. It is totally inert. So processing of this waste is very difficult. So it's rather better to recycle the waste at the site itself. So this waste is managed as per the Construction and Demolition Management Rules 2016. Like solid waste, municipal solid waste is managed as per the Municipal Solid Waste Management Rules 2016. So there is a separate rule for construction and demolition waste. So then we have discussed about I think street sweeping waste. So whatever waste materials we that is collected by cleaning of the streets and gardens, that is called as street sweepings. So that will have some organic fraction, or that will have some inorganic fraction, and also cleaning of the drains in that streets comes into that only. So, whatever there is organic fraction like leaves or food materials that goes for composting or other biological processing, and whatever inert material goes for landfill, and whatever dry materials like plastic, papers that goes for recycling and other facilities. But the waste or silt we that is removed from the drains, so that is not reused, rather that is sent for landfilling because that can have very high amount of contaminants and like heavy metals and emerging contaminants which can be very harmful. So that is directly sent for disposal. So after this, there was discussion about biological or biomedical waste, so which is managed through biomedical management rules 2016. So biomedical waste is also generated from the households like you know, needles, if, like needles, or there can be. So these waste are can be very contagious. So they should not be mixed with the municipal solid waste. Rather, that should be collected separately, stored separately, and collected separately, and sent to the facilities where biomedical waste is managed. So in hospitals and all, there is a different colored bins for different type of waste, so that should be followed. And then we have discussed about e-waste, that is the electronic waste. So electronic waste is something which is bulky, but it has lot of plastic, it has glass, it has heavy metals. So some of the valuable metals, although very low in concentration, but still that is present into the electronic waste. And there is proper sector, or I should say proper market to extract those heavy metals from these electronic waste, and then recover this, reprocess this, and then resell into the market. So that can be done, and there should be proper disposal of electronic waste also, because since I told you that there is a lot of metals, so if that will leach from these with time, from the waste with time, then it can contaminate or pollute the soil, water, surface, and groundwater. So So we have also discussed about these biomedical waste and e-waste. So some of these fractions can be hazardous. So then we have discussed about integrated solid waste management. So in integrated solid waste management, we not only discuss about it is not only about collection, segregation, and disposal of the waste, but it takes care of other aspects also. Like it takes care that that during this process, environment is not polluted, there is a social acceptability by the people, and also there is some economic benefit through processing of the waste. So the integrated solid waste management covers all these aspects, and we had a brief discussion about these, what are the elements, physical elements in the integrated solid waste management, and so on. And then we have had a separate lecture for solid waste management rules 2060. So rule is very it is very big, but a brief introduction and some uh, duties of what is the duties of the waste generators, what are duties of collectors and urban local bodies. All these were discussed into that lecture. And now we have week 12. So this is about finance and public-private partnerships into the municipal solid waste projects. So there is three lectures. So we will go through each lecture one by one, and then we will try to solve a few questions based on the lecture material. So first, let me share my screen. So, finance and PPP, that is public-private partnership in municipal solid waste management projects. So, managing of any waste or water, wastewater or solid waste, lot of money or capital is required first for making of the infrastructure, then maintaining of the various equipments and instruments, and also paying the salaries and for the all the workers working in that facility, and also for the health and well-being, and also to develop the green belt and for collection and everything. So money is required. So sometimes what happens that the urban the local municipality of that area does not have that much fund. So, and also previously it has been seen that when with public and private partnership, there is better and more efficient working of these facilities. So this is a clip that says that lack of access to finance key hurdle in municipal solid waste management. So there should be proper financing to for these facilities to work. So also, if we are developing some processing facility, so initially we will require some capital cost, and for some initial days. So for some initial time period, or in that can be in years, so that facility will not produce any generate any revenue, but after that some time, so revenue generation can be done. So till that time, we need that much money or amount to run that facilities and pay all the bills, so that that facilities process efficiently. So, full cost accounting, it is a semantic framework for identifying and evaluating the cost associated with the integrated solid waste management. So, it provides accurate and complete information on the real cost of managing the municipal solid waste. So, there are different types of the costs. So, it involves front end cost, which covers the land acquisition cost, the cost required for permits and building construction and other activities. Next is the capital cost. So this is the fixed cost for plant and machinery. So whatever equipments that will be required, that comes under the capital cost. Next is the operating cost. It involves the cost associated with the daily activities or in the plant. Next is the contingent cost, which involves the remediation cost. So if there is some pollution by the facility, then that will be managed by contingent cost. Next is back-end cost. So site closure, building and equipment decommissioning. So it comes under this, and also the retirement and health benefit for the current employees, that covers comes under the back-end cost. Next is the environmental cost. So cost involved in mitigating adverse effect on the environment. So whatever adverse effect on the environment, like it can have air pollution or water pollution. So all that will be remediated through the environmental cost. Next is a special cost. So it involves the aesthetic impacts, like can be development of the green belt, or making that area look beautiful or aesthetically pleasing. So that comes into the social cost. So these are the various elements of the full cost accounting. So full cost accounting has various advantages, like urban local bodies can use FCA as a planning tool for preparing budgets and determining future direction. So it helps the urban local bodies to examine various financial scenarios and their resulting impact in the futures. So it can also be used to analyze the cost into the long term, and it can also use for maintaining transparency between the urban local bodies and the general public. And this results from the FCA can be used to make more informed decisions. So each type of cost is discussed separately. So these there are some of the indicative front end and cost which takes place in a typical solid waste management system, like obtaining permit for the land, topographical survey, geotechnical investigation, geological investigation, hydrogeological investigation, waste characterization, quantification, and so on. So, so these are some. So each type we discuss separately. Next is the operation and maintenance cost. So this cost is something which takes place by daily operation of the various equipments into the that facility. So it shall include labor and salaries, administrative and management cost, maintenance of vehicles and equipments, fuels, tires, etc. etc. So the overall cost which comes through daily working or daily activities taking place in that facility. So it comes under operation and maintenance cost. Next is the contingent cost. So this include costs that might or might not be incurred at some time in the future, like remediating future release of pollutants. So this can happen or this cannot happen. So this cost can be best described in. So since it can happen in the future, which is not confirmed, so we can find it in the terms of probabilistic terms. So whether how much amount will be required if this happens, and what is the probability of happening that event. So this will include the cost for remediating if there is some future release of pollutants or if there is some leakage from the landfill. Like there can be release of leachate into the groundwater, or there can be release of landfill gas into the air, which can cause pollution. So whatever cost that will be incurred for remediating that will come under the contingent cost. So it also includes the cost required for compensating. So suppose there is some release of the leachate into the groundwater, it pollutes the groundwater, and suppose that groundwater is irrigate is used for irrigation purpose into the into the downstream side of that landfill by the farmers. So since now that groundwater is contaminated, so the farmers will not be able to use that groundwater, and the compensation to that to those farmers will be taken care by this contingent cost. So next is environmental cost. So the damage to environment is very difficult to quantify. Like there is lot of services which is done by our environment. Like there are uh, bees and other insects that help in the pollination, but to quantify that how much uh, uh, amount of money is saved by pollination by these bees and all is very difficult. So the environment cost is very difficult to quantify. So these are the implications on the environment that might occur due to municipal solid waste transportation, treatment, and disposal activities. So during transportation, treatment, and disposal, whatever pollution we are causing, that will be covered into this, like cause for mitigating contaminated soil, polluted surface and groundwater bodies, and poor air quality due to indiscriminate burning of municipal solid waste. So all these will comes under the environmental cost. So these are the cost of environmental degradation that cannot be easily measured or remediated, are difficult to value, and are not subject to legal liability. Such environmental costs often are termed externalities by economists. To truly capture all of the important life cycle cost elements, some people advocate assessing the upstream and downstream environmental cost of resource use, pollution, and water entailed in providing goods and services. So next is the social cost. So these are the costs incurred to mitigate adverse impact on health and well-being of the local community on account of improper management of the municipal solid waste management facilities. So if there is a not proper management of the all the waste coming into that facility, then whatever the adverse impact is there on the health and well-being of the local community, so that will be covered into this cost. But in India, such impacts are generally not compensated. Impact of municipal solid waste storage depots as well as treatment and disposal facilities on the health and quality of life and value of property in the neighborhood are considered. So, determining social cost is very important for planning efforts, and so it will take impacts of transport on the neighborhood along the routes that is taken to transport the waste from generation to that facility. So, there are clips on this, so we'll skip these. So there are grants from central or state government. So it has been widely recognized that urban local bodies are unable to meet the expenditure for their activities solely by internal resources. So they require some support, financial support from the state and central government in forms of grants and funds. So some of the grants and funds that are available to the urban local bodies are finance commission grants, central government grants like GN, NURM, Swachh Bharat Abhiyan, and so on, and state finance commission grants allocated by state to local authorities once every 5 years to support administrative governance and municipal service delivery. So urban local bodies can also take some loan. Sorry. So some of the financial institutions include the following like Housing and Urban Development Corporation, Infrastructure Development Finance Company, and so on. So, public-private sector participation is a beneficial option for financing municipal services while ensuring improved service delivery. So, for the functioning of the all overall municipal solid waste management, money is required in each step. So, the urban local body may not have that much fund, so they can approach state or central government, and they can also involve the private partnership because and there can be uh, a proper management of the waste by involvement of the private sector, and also there is lot of resources in the waste that can, if they is properly managed and recovered, and so rather than spending money on that waste, so a lot of money can be made by proper recovery and reuse of that resources into the waste. So this is a scheme from the central government like Jawaharlal Nehru National Urban Renewable Mission. So it is named on our first prime minister of our country. So this was launched in 2005, and so the mission is that which primarily to development in the context of urban conglomerates focusing to the Indian cities. So it the aim is creating economically productive, efficient, equitable, and responsive cities by a strategy of upgrading the social and economic infrastructure in cities, provision of basic services to urban poor and wide-ranging urban sectors, reform to strengthen municipal governance in accordance with the 74th Constitutional Amendment Act 1992. So the overall aim is to development and production of the infrastructure and upgrading of the um, urban poors and strengthening of the municipal governance in that area. So this figure shows the total value of solid waste management projects underway through JN NURM. So this is the total project cost, and we can see that the central share is nearly half, and state plus urban local bodies is the nearly half. So the share of the central government is nearly half or equal to the state or urban local bodies. So this is for different states. So here we can see that in states like Maharashtra, Telangana, and Uttar Pradesh, there is more involvement of private sectors in development and other things as compared to states like Rajasthan and Himachal Pradesh. So this figure shows so overall investment in projects in different states, and it shows the requirement of investment in creation of solid waste management structure infrastructure in the Indian states. So a case study of a financial failure project is discussed. So please go through these into the lecture slides. Now let's move to the next one. So this is about public-private partnership. So in public-private partnership, so there is an arrangement between the public, that is the government side, and private sector. So there is agreement or arrangement between the government and the private sector for the management of some assets and all. And here also the investment is made by the public entity for some time, and or it can also be taken care by that public partner. So there are some characteristics and pillars of PPP projects, that is risk transfer, there is value for money, output specification, promise of better project structure and design, affordability and efficiency. And so the private sector in solid waste management rules is discussed like in mid 1990s. So large scale projects in metro cities like Delhi and Chennai were not able to execute solid waste management projects properly due to inappropriate valuation and less scope of private participation. So during that time, there was very less private participation into the waste management. But in late 1990s, ULBs, that is urban local bodies, gradually realized to reduce the burden on landfills. Along with there was a notification of Municipal Solid Waste Rules Handbook 2000, making waste processing and development of sanitary landfill mandatory. So, and government was unable to spend money in infrastructure. So, public sector partners participation was involved in solid waste sector into the late 1990s. In late 2000, large private companies to get into collection transportation. Earlier, it was limited to local contractors also, and few integrated solid waste management have also been implemented under PPP mod. So, why PPP? So, there are various services which could not sufficiently managed by government agencies. Oh no, there is overlapping in this slide. So there is not, there can be some services which cannot be managed by the government, but that services are required to be provided to the citizens. And in that scenario, their involvement of private sector can be seen, where there will be that sector will give capital or investment for that management of that facility or services to the public. And so there is some fact like. We need to spend a lot in the infrastructure development. So there are some benefits of the PPE model. So like easy access to services, there will be a single window or one stop shop. There can be 24 by 7 convenience to the citizens, flexibility and saving of indirect cost and hardship. And government will also benefit it, like there will be minimizing financial outgo, better liquidity, production and against technology obsolescence, speedier implementation and efficiency is in management. And private partner will also be benefited, like they will have reliable stream of revenues. There will be low risk creation of employment, capturing business from relevant sectors, and invoking private sector skills, experience, access to technology, and innovation. So, these are the various models of PPE which is adopted in various Indian cities. So, BOT, or BOOT boot model, DBFOT, and DBO model. So most of the projects under PPP are under DBFO, that is design, build, finance, operate model. But most of the solid waste management products are under BOOT and DFO model, that is design, build, operate model, and design, build, finance, operate model. So we will discuss each model separately, like BOT model. This is the simple and conventional PPE model where the private partner is responsible to design, build, operate, and transfer back the facility to the private sector. Sorry, to the public sector. So the responsibility of the private partner is to make the infrastructure, and after completing of that, it is handed over to the private sector. Sorry, public side sector. So the role of private sector partner is to bring the finance for the project and take the responsibility to construct and maintain it. In return, the public sector will allow it to collect revenue from the users, and BOO model that is build, own, operate. So this is a variant of the BOT, and the difference is that the ownership of the newly built facilities will rest with the private party here. So after making of the infrastructure, uh, the private party will be the owner of the facility that is built here. Next is a boot model, that is build, own, operate, transfer. So this is also on the lines of the BOT. After the negotiated period of time, the infrastructure asset is transferred to the government or to the private partner. So suppose a facility is made, so it will be the responsibility of the private partner to make that facility and run or operate that facility for some period like 5 to 10 years, and after that period, that facility can be transferred to the government. Next is the build, operate, lease, transfer. So in this approach, the government gives a concession to a private entity to build a facility, own the facility, lease the facility to the public sector, and then at the end of the lease period transfer the ownership of the facility to the government. So in this model, so private sector will build the facility, they will own facility for some time, and after that they will lease it to some other public sector or public entity, and after completion of the lease period, so that property or facility will be transferred to the government. Next is rehabilitate, operate, transfer. So, under this approach, the government or local bodies allow private promoters to rehabilitate and operate a facility during a concession period. After the concession period, the project is transferred back to the government or local bodies. So, next is a DBFOT model, that is design, build, finance, operate, transfer. The most common form of PPP used where the private sector operator designs, build, finance, owns, and construct the facility and operates it commercially for the concession period, after which the facility is transferred to the authority. Next is a DBFO model. In this model, the private party assumes the entire responsibility for the design, construction, finance, and operate the project for the period of concession. So these were the various models and the processes which is involved in PPP projects. This first is the phase one, that is identification. Next is full feasibility, procurement, and operation. So phase one, that is identification, it takes place before entry to the PPP development pipeline. So the purpose is to identify and test projects so that the quality of the PPP pipeline is increased. And at the end of this phase, the sponsoring agency will have identified a project that is suitable for further development. This project then enters the PPP pipeline, which starts in phase two. So the PPP pipeline, that is the involvement of the private, starts in the phase two. In phase one, there is identification and testing of the project so that the quality of the involved PPP pipeline is increased. And in the phase two, more detailed study and preparation takes place. And responsibility for phase one will be with sponsoring authority like the ministries, and support may be provided by dedicated PPP agencies such as PPP cell or project development agency, and the sponsor may wish to engage external advisors. So next is the So in phase one, there is a strategic planning, project pre-feasibility analysis, suitability checks of the identified project to test suitability for development. And the first readiness check based on the results and output of the suitability and mode tool and the pre-feasibility study is done in the phase one. And an internal clearance should be taken within the sponsoring agency before projects moves to the second or it enters the PPP pipeline. And if there is a readiness check is in the favor, then this project is given internal clearance and it goes to phase two. So in phase two, planning and preparation for PP project management takes place. And here deciding on the best suited procurement method for the project is done, and the first draft of the key project documents is prepared, and applying for in principle clearance from the inappropriate or appraisal or clearance authority is done in phase two. And after phase two, if in principle clearance is granted, then the project is able to proceed to PPP procurement. It goes to phase three. So the important activities that should be carried out to prepare for procurement are expression of interest processes are described in this phase. So request for qualification and shortlisting is done in this phase, and final draft for of key bidding documents are discussed, and requirement and process for readiness check 3 and application for financial final approval are outlined. And finally, the contract finalization and award are covered in phase 3. And in phase 4, there is project management and monitoring. And this phase begins when the project reaches technical closure with the signing of the concession agreement. And the life of PPP during phase 4 involves implementation and operation of the project by the concessionaire and performance monitoring and contract enforcement by the sponsor. So the responsibility for phase 4 will be typically with the contract management team within the sponsor. So next is institutional framework. So the two bodies, important bodies, were set up to deal with the PPEs in India. So first is the Public-Private Partnership Appraisal Committee, and next is the PPP cell. So please go through these into the slides. So next is the financing schemes. So various schemes have been started to provide financing to PPE. Those so the important schemes are viability funding scheme. So it is an incentive scheme in which a certain percentage of the total capital cost is paid by the government to make the project economically viable. Next is the India Infrastructure Finance Committee. So this provides a long-term finance to viable infrastructure projects in broad sectors of transportation, energy, water, sanitation, communication, social and commercial infrastructure. And next is the IIPDF, so Indian Infrastructure Project Development Fund. It provides financial support for quality project development activities. So the quality sponsoring authority will thus be able to source funding to cover a portion of the PPE transaction cost, thereby reducing the impact of cost related to procurement on their budgets. So PPE in different states of India, many states in India already have PPE framework, and so 19 states in India have been shown as having PPE system in place. So out of all the states, there is PPE model in 19 states. So let's move to the last one. So this is about public-private partnership in solid waste management. So the outarching framework for management of municipal solid waste in urban areas were created by Ministry of Environment and Forest in 2000 with the enactment of Municipal Management and Handling Rules 2000 under the Environment Protection Act 1986 that entrusted the ULBs with the responsibility of the municipal solid waste. And there are two systems for solid waste management in India. First one is the centralized technology driven, and next is the decentralized community based system of waste management. And the integrated municipal solid waste management or processing and disposal will be mostly operated by DBFO model. And most of the decentralized system will be operated by the management control model. So you can refer these websites for reading PPM and MS PPs in MSMW projects. So these are overlaps. So after all these, so various municipal solid waste management projects are discussed in these tables, and what a model for PPE involved PPE model what which PPE model is adopted in these projects is given. And next, some case studies about different places is given. Like this one is about, I think, from Mumbai. The site is Gorai site. So this is the image prior to closure and after proper capping of the field. So this landfill looks something like this. Like there is proper capping and there is development of green belt on the landfill, and this one is properly sealed. So there were some challenges to for waste to energy, like First one is the NIMBY syndrome, like not in my backyard. Next is the waste may have very high moisture amount and inert content, and the waste which used to come was having low calorific value. So all these were the challenges for waste to energy conversion in this project. And there was some benefits, like there was improvement in the quality of the marine life after the capping and closing of proper closing of the landfill. So there was power generation from the methane which was produced from the anaerobic degradation. There was elimination of fire, health hazard, and breeding of flies and rodents, and so on. So, so there are some case studies, like this one is from Timarpur and Okhla project. So this is the landfill. We can see there is a lot of gases which is coming out from the landfill. So the budget for this project was 175 crores, which extended, and the waste is being shorted by the municipal corporation of that, and the failure factors for this was like unavailability of the EIA report to the public, and inadequate or unreliable waste characterization or quantification. So, proper characterization and quantification of the waste is very, very important before any facility. Like, what is the various fractions of waste that will come to the facility? What will be the properties? Like, what will be the calorific value? How much there will be organic matter? How much will be inert? And how much will be there in there will be the dry matter, and so on. So that is very important, and that was missing in this project, which leads to it failure. And protest against the plant because it air pollution is a major concern. So waste in transporting and tipping and transferring, it will be, there will be a lot of solid or soil and ash particle that can come into the air and they can pollute the air. So there was protest in the nearby areas of this facility. So next is the Coimbatore project. So this project capacity was 1815 tons per day, and it was developed under JNNURM scheme, and the concession period was 20 years. Next is the Tirupur project. So um, in 1990s, so this place faced difficulty for managing the waste, and in 1999, IBR Infrastructure and Projects Limited, and under boot model, and in 2000, the construction of the plant got completed. So the concession agreement was that 40 metric tons of biodegradable waste should be provided, and an IBR, that is this company, will pay 3.5 per ton, and private concession took land on lease of 1.75 lakh per annum, and the plant cost nearly 55 crores. So we can see, so there is also overlapping. So next one is about Asansol project, which is in West Bengal. So this was involvement of private partnership through boot model, and uh, so the failure was due to biasness of placing of the bins by the and influenced by the local political leaders, and it leads to the failure. And here is the few failure project cases in India. So this one is from Lucknow. So this problem is due to absence of appropriate toll or tariff capacity building of urban local bodies and public air awareness. So we can see a lot of litter lying onto the ground. So this was all for public-private partnership into the solid waste management. And so we have seen that even though there is involvement of private partnership, still there is lot failures we have seen into the management of the waste. So this can be due to improper data about the waste, like there is not proper quantification of the waste, and there is not proper implementation. So management of municipal solid waste in our country is a very challenging task. So, since we are also moving towards becoming developed, slowly we are developing. So, with development, there will be more and more solid waste that will be generated, and more amount of waste will needed to be managed. And also with as we are moving towards becoming developed, so the rack pickers or the kabadi walas which are involved, so their number will reduce. And slowly in India now, the uh, informal sector like rack pickers have very big role to play, but slowly this informal sector will shift towards the formal sector. So there will be waste to be properly managed by government and the public partners, and that will be managed by them. But anyhow, waste management will be a very challenging task for our country. So now let's move to the questions based on this. So let me first share my screen for the questions. So the first question is, which cost processes come under land acquisition and permits related to the project? A, front end cost, B, back end cost, C, capital cost, D, special cost, or E, all of the above. So we have to find out the cost which is taken care, which of the following takes care of the land acquisition and permits cost. So I'll give you all 2 minutes. Just take your time, write the option in the chat box, and then we will discuss. Sorry, the audio was mute. So the question is, which cost processes comes under land acquisition and permit related to the project? A, front end cost, B, back end cost, C, capital cost, or D, social cost, or E, all of the above. So I'll give you all 2 minutes. Just take your time, write the option in the chat box, and then we will discuss which one is the correct. So the cost required for land acquisition and permits is covered under the front end cost. So A will be the correct answer. So now let's move to the next question. So the question is, which cost processes comes under operation and maintenance cost involved in daily activities related to a project? A operating cost, B back-end cost, C capital cost, D social cost, or E all of the above. So again, I will give you all 2 minutes. Just take your time, write the option in the chat box, and then we will discuss which one is the correct. So the cost process comes operation and maintenance cost involved in daily activities related to a project comes under operating cost. So A will be the correct answer. Let's move to the next question. The question is, which cost process comes under quality of life and aesthetic impacts involved in daily activities related to a project? So again, I will give you all 2 minutes. Just take your time, write the option in the chat box, and then we will discuss. So, social cost covers the cost which is involved through quality of life and aesthetic impacts. So, A will be the correct answer. Let's move to the next question. So, the question is, which cost process comes under site closure and retirement and health benefits for current employees involved uh, in daily activities related to a project? A, operating costs, B, back-end costs, C, capital costs, D, social cost, or E, all of the above. So again, I'll give you all 2 minutes. Just take your time, write the option in the chat box, and then we will discuss. So site closure and retirement and health benefits for the employees comes under backend costs. So B will be the correct answer. So now let's move to the next question. So the question is, which of the following are advantages of FCA? That is full cost accounting. And that first option is urban local bodies can use FCA as a planning tool for preparing budgets and determining future direction. B. FCA helps the ULBs to examine various financial scenarios and their resulting impacts in the future. C. FCA results can also be used for maintaining transparency between the urban local bodies and the general public. Or D. All of the above. So again, I will give you 2 minutes. Just take your time, write the option in the chat box, and then we will discuss. So all the three options are the advantages of FCA. Like FCA, it can be used as a planning tool for preparing budgets and determining the future direction. And also FCA helps the urban local bodies to examine the various financial scenarios and their resulting impacts in the future for the project. And FCA results can also be used for maintaining the transparency between the urban local bodies and the general public. So D, all of the above is the correct answer. So now let's move to the next question. So the question is, which of the following are benefits of PPE model? So first is easy access to service, C creation of employment, D efficiency in management, C. Efficiency in management. D. Protection against technology obsolescence. Or D. E. All of the above. So again, I'll give you 2 minutes. Just take your time, write the option in the chat box, and then we will discuss. So all the given options are the benefit of PPE model, that is public-private partnership. It gives easy access to the service to the people. It creates employment. It increases the efficiency in management and protects against technology obsolescence. So E, all of the above will be the correct answer. So let's move to the next question. So the question is, in which phase of PPE project first draft of the key project documents are prepared? A, phase identification. B, full feasibility. C, phase 3 procurement. Or D, phase 4 operation, that is project management and monitoring. So again, I'll give you 2 minutes. Just take your time, write the option in the chat box, and then we will discuss. So, the key project documents are prepared in phase two full feasibility. So, in phase one, identification, so strategic planning, feasibility analysis, suitability checks, readiness checks, all these are done in phase one. And in phase two, the final draft of the key project documents are prepared, applying for in principle clearance from the appropriate appraisal or clearance authority is done. So all these and done is for phase two, and in phase three, uh, uh, expression of interest and EOIU processes are described, and request for qualification and shortlisting is described, and the final draft of key bidding documents are discussed in the phase three, that is the procurement, and is phase four, that is operation, project management, and monitoring. So this phase begins once the project reaches technical closure with the signing of the concession agreement. And the responsibility of phase four is with the contract management team within the sponsor. So in phase two, that is full feasibility, final draft of the key project documents are prepared. So B will be the correct answer. Now let's move to the next question. So the question is, in which phase of PPE projects contract finalization and award are covered? A, phase 1 identification, B, phase 2 full feasibility, C, phase 3 procurement, or D, phase 4 operation. So again, I'll give you all 2 minutes. Just take your time, write the option in the chat box, and then we'll discuss. So the project contract finalization and awards are covered in phase 3, that is procurement. So C will be the correct answer. So now let's move to the next question. The question is, in which of the following financial schemes is an incentive scheme? So question is, which of the following financing schemes is an incentive scheme in which a certain percentage of total capital cost is paid by the government to make the project economically viable? A viability funding scheme. C. Indian Infrastructure Finance Company. C is Indian Infrastructure Project Development Fund, or D, none of the above. So again, I'll give you all 2 minutes. Just take your time and write the option in the chat box, and then we'll discuss. So, viability funding scheme is a scheme in which a certain percent of the total capital cost is paid by the government to make the project economically viable. So, A is the correct answer. So let's move to the next question. So the question is, which of the following are the challenges for waste to energy plant or facilities? A. High moisture and inert content. B. NIMBY syndrome, or C. High calorific value waste, or D. All of the above. So again, I'll give you 2 minutes. Just take your time, write the option in the chat box, and then we will discuss. So the challenges for waste to energy facility plants are that if the waste has high moisture and inert content, then it will be very difficult or to incinerate the waste, and because of very high moisture content, lot of energy will be required to remove the moisture. And if there will be inert content, then we know that inert content do not combust and do not give any energy, so the overall energy production will be very very less. And NB syndrome, that is not in my backyard, so this is something which people don't want the facilities, waste management facilities to nearby their localities. So NB syndrome can be one of the challenge. And see, high calorific values. So if the waste will have very high calorific value, then it will be very good for incineration and other processes like gasification and pyrolysis. So A and B will be the challenges for waste to energy plants. That waste with high moisture content and inert content, and B nimbus technology. So these were the questions based on week 12 material. So I hope all the questions and content is clear to you. So thank you so much for joining. So we will meet on next Saturday for the last problem solving session. So let's meet on next Saturday from 6 to 8 p.m. So thank you so much for joining. Have a nice day. Thank you.